this is Dr. Karthik here again. I welcome you all for the second session, and this session will primarily focus on the Python programming perspective of image processing and computer vision. And in case if you have not listened to my session one, I would suggest you to go back, listen to the session one, so that you'll be able to better appreciate of whatever I'm going to talk in this session two as such, right? And right, let's get started. Let's get a deep dive into this world of image processing and computer vision. Right, this is a quick recap, and this is the session two plan. Right, I'll give a quick recap of what happened in session one. I'll talk about some more applications of image processing and computer vision, and I'll also talk about the Python programming. How do you get started by using Python programming in the field of image processing and computer vision? I'll also briefly introduce about the Google Colab environment. So this is the main agenda for session two, and let's get started. Let's get started here. And this is a quick recap, right? And we have seen lots and lots of applications and the kind of scope that the industrial image processing these days, right? And whether you can be a metallurgical engineer, whether you are a chemical engineer, whether you are a civil engineer, no matter what kind of engineering discipline you come from, image processing and computer vision play an extremely crucial role in your career, right? And there's a huge need for engineers in this particular domain. Because in every industry is looking for an automation, and while automating their processes, vision sensors plays an extremely an important role, extremely an important role, right? And the domain also play a very important role, right? So it's not only that when you're applying for a civil engineering domain, it's equally important that at least you need to know the domain of that engineering problem that you're working for, right? So that is another crucial thing here, right? And the cost of data acquisition is high for certain applications, right? As I said about in the last session on the satellite imaging, underwater images. So these two extreme cases, if you see, the cost of data acquisition plays a very an important role, right? Just the way you capture images again and again by using your mobile phone. If your images doesn't come well by using your mobile phone, you take a selfie and it has some kind of a blur in the noise. What's the best thing that you will do is you will definitely will take another picture, okay? But it will not be the case in every other scenario as well. So it's equally important to know that, right? And image processing, there will be a huge cost that will be incurred in taking images in some extreme scenarios like satellite images and underwater images, and the cost of right, and that is where your role as an image processing and computer vision engineer comes in, right? Where you will work towards improving the quality of those images. Okay, and there's a quick recap, and these are some more applications which I thought of introducing you. Forest inventory counting, right? And when we a leading paper manufacturing client who came to our team and requested for this application on forest inventory counting. Okay, so what he wants us to do is he wanted to count the number of trees in the forest, and he also wanted us to identify how many what kind of trees are there and what kind of species are there and how many trees belonging to a certain species. So all these things he wanted us to do. Okay, so it will be very difficult for people to do it, but nowadays with the advancements in deep learning, artificial intelligence, all these areas, and especially the 3D image processing, right? All these areas put together, it has become very easy for us to do some of these tasks. Of course, these are extremely challenging to capture the data. What we did was we used a drone and then flew the drone across the forest, captured the top view, and then we started identifying what kind of trees are there, how many number of trees are there, and how many number of trees belonging to a certain species are there, and the tree height. So all these we were able to identify through this application. And the next one is a warehouse monitoring. If you take an example of a Flipkart or an Amazon, right? These days, they have the huge warehouses, and for them to maintain the stock, it will be very difficult. Okay, so now if you want to automate this process of stock maintenance, Okay, what's the best thing that you can do is you can manually, if you want to do it, so you have to use a laser scanner, scan each and every barcode, and that's how you will keep a stock maintenance back into your database. Okay, but however, this is a human involved process, and it's a quite laborious process. Okay, it's a time taking process. So if you want to do a regular stock maintenance, okay, it'll be very very difficult, and it's a time consuming process. Now how about use a drone? Because nowadays, if you have to do a Paytm transaction or a phone pay transaction, you are using your mobile phone and reading the QR code. That is what you're going to do, right? Here, QR code is some form of a barcode, nothing different as such, right? Now, that means you're using your camera to do it. Now, what instead of using a laser scanner, what we have proposed, what kind of solution we have proposed is we used a drone and we installed a camera along with the drone, and then we made sure that the drone goes in an automated manner, and then it scans all the barcodes, and then so that the stock maintenance happens at the back end, right? This is very very interesting application. It's a very patented solution that we have offered to one of our client who worked with us. And then the other one is the high voltage transmission lines inspection, the windmill inspection, right? These two applications also, if you see, the data capture mechanism will be extremely challenging. Okay, remember the basic block diagram in the first session. The first step is the data capture. Okay, so how well you design this data capture block is all plays a very very an important role in the quality of the images that you capture, right? Or the videos that you capture, for that sake. Right now, if you must be aware of, right, you must have seen this high voltage transmission lines. They're very very huge, and it will be extremely dangerous to operate in those regions. Okay, but it's equally important that for the well functionality, so that the power transmission happens very well, very efficiently. Okay, it's equally important that you should ensure that all the parts of the high voltage transmission lines are working perfectly fine. Okay, so if you are able to ensure that, okay, if you are able to ensure that, then uh, the- uh, then you will have a power transmission very very effectively. Okay, so in the same way, for the windmill inspection, the windmills are installed in a places where there heavy winds and the very huge structures. Okay, if you want to do a regular maintenance checkup, it will be very very difficult at such huge heights. Okay, so what's the best solution that we were able to offer is we flew the drone to that place, to that location, and ensured that it's not very close to the high voltage transmission lines especially, but we were able to capture a few images, and then we were able to develop some AI and the deep learning based solutions in order to identify if there are any defects in those transmission lines or the windmills which are installed. And especially the windmill. Okay, one of the biggest challenge is that you have to design a drone which can withstand the huge winds in that particular height, right? It's a huge height. Okay, at that height, you should ensure that your drone will be able to withstand such huge winds. Okay, that is another crucial application that our company worked with. And the document digitization, of course, in tomorrow's session, in the session 3, I am going to talk about more about document digitization. Okay, so where do you get started as a beginner? Okay, see, you take an image, okay, from by using your either your cell phone camera or a DSLR. Okay, where is the foundation for that image processing functionality is coming from? Okay, it's your human visual system is is what has inspired and led to the invention of this camera or video cam, whatever you call it as. Okay, so now let's try to understand some of the most important components. I'm not going in-depth details of human eyes, okay, human visual system, but however, I want to talk about two components over here, the one being rod and the other being the cones. Okay, rods are mainly used for detecting intensities, whereas cones are mainly used for detecting color information. Okay, if you see here in this slide, right, you have three different types of cones. One is red, other is green, and the third one is blue. Okay, that means the red color cones will detect the red wavelengths. Okay, the blue color cones will detect the blue wavelengths, and the green color cones will detect the green wavelengths. Okay, but it's not only these three colors are there, right? In the visual spectrum, the range of visual spectrum ranges from 400 nanometers to 700 nanometers. Okay, it's equally important that you have to detect all those colors, else you'll be able to identify only red, green, and blue by using your human eyes. Okay, but your human eyes is much more robust, and the visual system itself will capture several different wavelengths, several different colors, right? It'll be able to interpret them. How they will be able to do is, it's a combination of these red, green, and blue, which results in multiple other colors as well. Okay, and now this is how the basic images are formed. There's an illumination source, and the light is coming and falling onto the scene element and getting reflected back and reaching the imaging system. In this case, it can be a camera right over here, and now inside your camera there are matrix of sensors, right? There are a matrix of sensors which captures the scene elements extremely well. Okay, and now if you see, the incoming light which is coming is analog in nature, but however, in order to store the information which is coming from the reflected light about the scene, right? If you have to store the information, you have to convert this analog signal into a digital signal first. Okay, and the digitization happens, and now after it gets digitized, and by applying some advanced image processing algorithms related to image compression, okay, you will store the image back into your database. Okay, this is how images are formed. Where do you think the motivation has come from? The motivation for this image formation has come from your human visual system. Okay, human visual system also have a sensors. It's a much more robust than what we use as a CMOS or a CCTV sensors in our mobile phone cameras, or for that sake, any other cameras as well. Right. So now this is how the images are formed in our imaging system. Okay, but if you see, now there are two kinds of images, right? The one being in the visual range, at least one is a grayscale image, where only the intensity information is there. There is no color component in it, but however, every scene element is represented by intensities ranging from 0 to 255 for an 8-bit image. Okay, and now so when a certain, as shown in this slide, if you see a certain pixel intensity, that means here also it's nothing but, if you see, this image is in the form of a 2D matrix now. Okay, so individual 2D matrices, individual elements of this 2D matrix actually represent the intensity. Okay, and the value taken by each element in this 2D matrix depends on the amount of light that is received onto this particular sensor. Okay, on the sensor which is capturing the information related to this pixel value, so the pixel location. You're right. And here, if you see, it's 112. That means this 112 number is decided based on the amount of light that is coming into this camera system reflected from the scene element. Okay, now now the color images, the other kind of images are the color images, where you have red component, green component, blue component. Okay, similar to the way human visual system has red, green, and blue cones, which detects the color information. Okay, that is where the motivation of representing a color image with R, G, and B has come from. Okay, now all these red component is represented by a 2D matrix, green component is represented by a 2D matrix, and the blue component is represented by an individual 2D matrix. Okay, of course, all these individual components, okay, the size of these matrices which represents these individual components of red, green, and blue are of same size. Okay, so that means when you are reading these images programmatically, okay, so the output variable will be of array type. Okay, for reading a grayscale image, it will be of 2D array, while for reading a color image, it will be of 3D array. Okay, and the other colors, the way human visual system is able to generate the other colors other than the red, green, and blue by the combination of red, green, and blue. Okay, in the same way, here the other colors in this color image are generated by the multiple combinations of this red, green, and blue components. Okay, so we look at some Python programming elements for this color image as well. Okay, these are some of the useful Python packages for image processing. OpenCV, Open Computer Vision Libraries, okay, which has a rich repository of image processing and computer vision functions. Okay, and right, NumPy is another package that we have, which is extremely useful for fun. Has some very very efficient array processing related functions. Okay, and scikit-image, scikit-learn has some machine learning libraries in them, right? And something like if you want to use SSIM as a metric in order to measure the performance of your image restoration algorithm, you can find in in these scikit packages, right? And matplotlib is another package, right, where you have for plotting the information, whether you want to plot the graphs, whether you want to plot the images, right? Matplotlib has all of them. Okay, and now another one is TensorFlow, right? TensorFlow is one of the useful deep learning library, and the Python image library is one of the latest image processing library. Of course, you may have some functionalities which do overlap with the capabilities that OpenCV has. Okay, but however, they might be very very minor difference. But it's equally important that when you're writing your Python program, it's equally important that to understand about each and every function. Just because IMRead is there in OpenCV and also IMRead is there in PIL or Matplotlib. Okay, it doesn't mean that every IMRead in all these packages behave in the same way. Okay, so you have to read the documentation and you have to understand it. Okay, this looks like quite laborious process, let me tell you, but when I started this Python programming, actually I was literally scared. Okay, but I think today I enjoy a lot. It's really worth spending. And in case if you already know C language or C++ or Java, okay, Python is extremely simpler than C, C++ or Java. Okay, and C, C++ or Java are more difficult. Okay, and when I speak about image processing or a computer vision, many students or faculty whom I have interacted with, they have used MATLAB in order to execute their algorithms. However, MATLAB is not what do you say? It's not a free software, and majority of the industries today actually prefer as far as possible, because if you need some specific MATLAB functionality, of course there's no other way to go other than go to MATLAB. But however, in majority of the industries, because that Python is an open source language, Python programming is majorly preferred over MATLAB, and MATLAB is computationally intensive. Okay, it's very very, it'll take longer time for you to execute the same program in MATLAB when compared to the Python program. Okay, these are some of the useful Python packages. Okay, so let me go to some practical session. This is the Google Colab environment, right? And this directly comes from Google, in fact. Okay, and you have right, and one of the biggest advantages here is you can perform all the deep learning related stuff at free of cost, right? If you have to perform the deep learning related stuff, you will be what do you say? You will have to buy GPUs. Okay, but Google is offering free GPUs, access to the free GPUs, of course, with a limited time, for a limited time duration. Okay, and now this is how. And one of the key thing here is you have to find a place where you will read images and write the results back after you process your images. Okay, and Google Colab itself offers you some free space. Okay, but the problem with Google Colab, the space offered within the Google Colab, the virtual space which is offered as a part of a Google Colab environment, okay, it will it will expire and your data gets erased. Okay, once your session duration is over. Typically, your session duration varies between 8 to 12 hours. Okay, after which you may have to wait for some time for you to get again the GPU access. Okay, but however, for the majority of the student related projects or the research based projects, Google Colab should be absolutely fine. Okay, and right, and so you have to find a place for it where you can write or read the data, for which what we will use is we will import and mount the Google Drive, okay, into our Colab environment. Okay, So these are the two commands. If you see, these are the two commands which we'll be using for importing the Google Colab environment within Google Drive within the Google Colab environment. Okay, and once we execute this, it will give this link. Okay, and we will go to that specified location and get the authorization code where we will enter and press enter, and then it executes. Okay, and one small challenge with Google Colab is sometimes it gets disconnected in between. That's the reason I'm not executing in live. But however, these are the two commands that you have to use. Okay, and right, and this is a command which you can use to understand how much of NVIDIA GPU that is assigned to you. Okay, NVIDIA -SMI. Okay, so if you see here, almost 16 GB GPU RAM has been allocated to me. Okay, if I have to buy the 16 GB GPU RAM, okay, it'll be running into a couple of lakhs. Okay, that's a kind of resource that you'll be getting through this Google Colab. Of course, it's only, I'm talking about only Google Colab, but there are several other platforms available in Kaggle which provides this GPU resource, but I found Google Colab as little comfortable. Okay, so now once I have mounted my Google Drive into the Google Colab environment, okay, so what you can do is you can shift to appropriate drive. Okay, Select Smart Demo is the folder where all my images are there. Okay, and right, and if you see here, and what is that I'm trying to do over here is import CV2. Okay, import CV2 is where you will import your OpenCV libraries into your Python program. Okay, so that you can make use of them. This import CV2 is very similar to your C programming construct. Okay, hash include stdio.h, right? So that is what you will use to import standard input and output functionalities, or the standard input output header file into your Python program, right? In the same way, you will use import CV2 and then to import some of the functionalities within the OpenCV libraries. Okay, and import matplotlib.pyplot as PLT. Okay, so what I'm trying to do by using this is, okay, to display an image, I'm using matplotlib package. Okay, however, there are some workarounds where you can use your OpenCV function itself in order to display your image. Okay, but here what I'm trying to use here is I'm using matplotlib here to display, so that you understand the how to use multiple packages but still within a single program and still execute the Python program, right? So that is what I'm saying, right? So you may have IMRead in OpenCV as well as matplotlib. Okay, but you have to understand what does IMRead in OpenCV does and what does IMRead in matplotlib does. Okay, the basic difference between both of them, it's very, very important for you to understand. Okay, so I am using cv2.imread, okay, in order to read the information regarding the cameraman image. Okay, and I have passed this parameter of 0 into the imread function, so that I want to ensure that I want to read in the grayscale format. Okay, so when I'm printing this image, img variable here, if you see, that's a 2D array. That's what I was saying, right? The grayscale images are represented by a single 2D matrix. Okay, it's a 2D array. In other words, you call it as a 2D array as such, right? And now here, once after you do that, and if I see this, I am using now plt dot imshow, and then in order to display my image. Okay, and right, and I am mentioning that cmap equal to gray. This, if I don't mention this parameter, there is some kind of a pseudo coloring effect that happens. Okay, in order to display the true color rather than the pseudo color, I want to ensure, so I pass this parameter called cmap equal to gray, and plt.imshow of img is what displays this image. Okay, if you see here, this is when I'm using display, and this is how it's get displayed my grayscale image. Okay, and let's go with the color image, how it happens, right? I use imread function, okay, cv2 imread, okay, and mandrill.png. This is the image I want to read, okay, and displaying this implt.imshow of img, and I have this image, okay. But mandrill image doesn't look like this. It looks like this, okay. So here, if you see carefully, observe, I'm using imread from the OpenCV library, and I am using imshow from the imshow from the what do you say, matplotlib library, okay. And now if you see, these are two different libraries that I am using, okay. The functions are coming from two different libraries, and it's equally important for me to understand about the functionality of each of those functions coming from these two different libraries, okay, to perform some kind of an image processing operations, okay. imread from OpenCV, when it's reading an image into a variable img, okay, it is on the form of a 3D matrix. As you see here, print img.shape, it gives me 288 comma 288 comma 3, okay, 288 comma 288 comma 3. This is what it gives me, okay. And now after this 288 comma 288 comma 3, okay, if you see the third dimension, 3 indicates that there are three different components over here. The first component, OpenCV libraries interpret as blue. The second one, it interprets as green, and the third one, it interprets as red, okay. But when matplotlib is displaying an image, it will assume that the first component indicates red, the second component it indicates green, and the third component indicates blue, okay. It's completely a reverse interpretation that matplotlib or majority of the image display systems has, okay. So you need to do the appropriate color transformations before you can display an image, so that you'll be able to see the clear color, an accurate color as such, right? And img is equal to cv2.cvt color, okay, of img, comma cv2.color underscore bgr to rgb, okay. So I'm using this bgr interpretation of OpenCV to rgb interpretation, okay. And I'm using this cv2 cvt color function, right, in order to do this operation, okay, in order to do this operation, right. And when I'm displaying the image, if you see, the images of true mandrill's image, okay. And when I'm printing the shape, it's 288 comma 288 comma 3. The first component is rows, number of rows, and 288, the second 288 is the number of columns, and the third component is a 3, which represents the color information, okay. So to summarize this collab, right, Google Colab is an offered by Google, and if you have a simple Gmail account, that itself will be sufficient for you to do it. And to store images and read images, it's very important that you need to mount your Google Drive first, okay. And this is how you can mount your Google Drive. And when you are reading Grayscale, maybe you want to use this parameter 0, so as to doubly ensure that img has only Grayscale information. That's a single 2D matrix, okay. And when the reason it's called Grayscale is the intensities in the Grayscale image vary from 0 to 255, okay. And if you see here, when I'm reading a mandrill image, right, by using OpenCV library, the first component gives me blue, the second component gives me red, and sorry, the second component gives me green, and the third component gives me red, okay. But majority of the image display systems assume that the 3D matrix, when the 3D matrix is given as an input to imshow function, okay, the majority of the image display systems assume that the first component is red, and the second component is green, and the third component is blue, okay. And right, since the interpretation of OpenCV imread is something different, what we are trying to do over here is appropriate color transformations before we display back the image, okay. And right, so this is about the Colab environment and the fundamentals of the Python program, right. And I hope you learned something today. What I would recommend is, before you go to session 3 and listen session 3, do some experimentation, okay, with Colab and write some small pieces of code, and then write it in Colab, and then do some small experiments. Do that so that you will get comfortable with Colab. Okay, carefully use this video and then pause at appropriate times, and then ensure that you execute the programs whatever I have shown you today. Okay. Had it been the live session, I would have shared the Google Colab notebook. However, I'll see if there is feasibility for me to share this Google Colab notebook at the end of third session. Okay, and hope you have learned something. Stay safe and stay secured. And let's get back again in the third session where we'll be learning some more details about Python programming with an application of in the applied to OCR technology, right? Optical character recognition technology. Until then, bye.